So to start with, I am Sharad Kumar Agarwal, Professor Bridge at IRICEN, and today's topic for discussion is about inspection and maintenance of bridges in general. Of course, in due course, we will cover the various types of bridges. So bridge is a structure that is built over a river, road or railway to allow people and the vehicle to cross from one side to another side. Basically, if we got a gap in our right of way, then we try to make that gap or build a bridge so that the vehicle or the movement can be made through that. Now, what are the main elements of the bridge? We can divide the bridge into, say, typically superstructure and substructure. The superstructure includes track structure, girder and the bearing. Traditionally, railway we consider bearing is a part of superstructure. However, in other than railway, many times bearing is considered as a separate entity and it is a totally a mechanical device or something like that. So there is a confusion, but in railway we consider it is a part of the superstructure. Then in substructure we start with the bed block, river training and protection works, pier, abutment, wing wall, then foundations. So these are the typical two part we can say for the bridge. There are another kind of bridges which can be called monolithic bridge, that can be like pipe culverts, box culvert, arch, etc., where we don't have any difference between superstructure and the substructure. Typically, you can see the main elements of the bridge. Top of the bridge is the girder, that is superstructure. Then along with that, we will be having the bearing. Then comes the part, you can say this is the pier cap. This is the pier. Then the foundation, and on top of that, here we have shown the pile as a foundation, and then the pile cap. So generally pile cap should be a part of foundation, but many times it has been referred as a substructure also. We can say pile as a foundation, but again this is somewhat a gray area. Normally pile cap is designed along with the pile. Classification of bridges, we can say typically we can say track bridges are those bridges which are suitable for the railway vehicle. They can be over water body, that is river, nala, canal or something. Many times we call them the hydraulic bridge also. Then there is another category that is known as the viaduct. Typically when there is a lot of dry land or the air through it instead of having the water, then it can be railway over railway. So ROR we say many times, or it can say railway flyover. When many times if the road is under the railway, then we say road under bridge. Okay. Then we are having the road over bridge. When the road bridge is over the railway. Some of the pictures shown here. This is the old picture of the Paman Bridge, which has been recently converted into a vertical lift bridge, and it has been inaugurated by PM some time back. So it is the old one. Then this is example of road under bridge, road over bridge an example. Typically I have shown you a figure which has had some failure. So we need to worry about the failures and how we can prevent the failures by way of doing inspection and timely maintenance. According to function of the bridges, I can say it can be rail cum road bridges. See, bridge is a very costly asset, and many times we will not have that much of the financial freedom to make more number of the bridges. When already road bridges are being made, we can convert the road bridge as a rail or road bridge, or other way around. We can have a rail bridge and then we wanted to utilize this for rail and road. Many times we plan in such a way that we build both the bridge one above the above. It can be side by side like that. So this will be rail come road bridge. Then we are making the bridges which is typically used by the pedestrians. So it can be a foot over bridges. Normally we may having a pipeline crossings. When the pipeline is crossing above the railway track, it will become a pipeline bridge over railway. Many times canal or the water is crossing above the bridge, then it can be an aqueduct. Some example of the rail come road bridge, it is a bogeybill bridge. Here you can see is the road, and here we can see the rail track. This is a typical example of foot over bridge in the railway premises. According to the material of construction of the superstructure, we can decide or we can classify the bridges. It can be a masonry bridge, it can be arch, stone masonry arch bridges, or the brick masonry arch bridges. Then the masonry can be with the lime mortar or cement mortar. We can have the steel superstructure, and accordingly steel superstructure can be further subdivided into three groups. It can have the riveted connection for the joint, it can have the welded connection for the bolted connection. Now in bolted connection, normally we have the ordinary bolt or turn bolts and the HSFG bolt and so on. Then when it comes from steel, we can graduate to concrete. So it can be reinforced concrete bridges, RCC bridges. When we are pre-stressing the concrete, then it becomes a pre-stressed concrete bridge. Next, we can have the composite bridge. Composite can be pre-stressed composite bridge, or it is a steel concrete composite bridge. One beautiful example of arch bridge, typical, you see the immaculate nature of the arch bridge without any defect, etc. It's a very good clean bridge. Of course, you can see some of the masonry, the blocks are getting some weathering action, but it can be easily repaired, and of course the age of this bridge will be not less than 100 years. Stones having some sign of efflorescence. This is the brick is having sign of efflorescence, or you can say this is the brick and stone arch masonry bridges. There can be steel truss bridges. Here it is a deck type of steel truss bridge. The entire steel structure here you see, and on top of that we have got the deck. This is a road bridge. It was functioning in US. It has been failed in 2007. So particularly I use this example so that I can talk some about the failure cases related to this bridge. This is a riveted connection. We have got the gusset plate connected with the members. This is the same bridge. It is a 2003 photo and it has failed in 2007. Another example of joints at the time of construction or fabrication of the steel bridges. Here we are using the bolts rather than rivet. Then that steel bridge can be a welded bridge. You can see this joint here, it is particularly welded. This example of steel welded plate girder, you can see this all this structure is welded, and it is a plate girder deck type of arrangement. Then comes the detail about the plate girder bridges. In that, we will be having two eye leaves, one eye leaf here and another eye leaf. And in these two eye leaves, they are joined by the cross bracings or the cross frame. On this type of this is the cross frame. Then these are joined with the lateral bracings. Depending upon the requirement, there can be a multiple number of the uh, flange plates. Here you can see there are 1, 2 and 3 flange plates. Similarly on the bottom also 1, 2 and 3, depending upon the required moment of inertia to counter the bending moment as well as to control the deflections. Then another part of this plate girder bridge is the stiffener. So this at the end near about the bearing, we got a bearing stiffener, and all the other stiffeners we can say are the intermediate stiffeners. So this bearing stiffener and intermediate stiffener, they are having very important role to make the main eye girder perform effectively. Similarly, this cross bracing and the lateral bracings. See, the main eye girder is the primary member. However, this cross bracings and the lateral bracing are the secondary member. Now in this view, you can see the deck is also placed on top of that. Now one point here is to understand, whenever we are analyzing bridges or the beams or the girder, we typically assume it as a line element and then we do analysis for the bending moment, shear force, etc. Actually, these structures are three-dimensional, they have finite depth, and because of the finite depth, when they subjected to bending, the end of these bridges get rotated, and because of the rotation and because of the finite depth, there will be lot of change in the length of the top fiber as well as the bottom fiber that need to be taken into care at the time of further analysis, and that need to be seen that there is adequate space available for the bottom fiber or the top fiber to deform, so that they will able to let the bridge to function properly, otherwise it will generate secondary stresses. Now the component of the plate girder bridges, let us see the top flange. Top flange being a member carrying the compressive stress, and because it is carrying the compressive stress, as I already told you, top fiber will be having some shortening in the length. Then web plate near bearing, due to heavy concentration of the stress, a web plate near the bearing likely to buckle, and in order to prevent the buckling of the web plate near bearing, we are providing the bearing stiffener. Then the next item is cross frame, angles and top lateral bracings. These are primarily connecting both the leaves of the girder bridge, and thereby it is going to increase the moment of inertia in the lateral direction tremendously. See, take and understand this. Say this is one simple eye girder and you got another eye girder. At the max, your moment of inertia will be 2 times of the eye girder when they are not connected together. But when you connect them together, then their moment of inertia increases multifold depending upon the spacing of these two girders. So that we need to understand, and that is why the cross bracings, even though it is a secondary member, it is having a very important role to join both the girder together and take care of lot of lateral loading such as the raking force, wind force, earthquake force, etc. etc. Another item of particular importance is the frozen bearing. See, as I told you, because of the bending, deflection, and the rotation also take place. And when end is rotating, the bearing of the girder or the bottom flange need to move from its mid position, and if it is not permitted to move or deflect, then it will attract like some eccentric forces and thereby induce bending stresses in the plate girders. So that we need to understand, and this can be because of the variation in the temperature, or it is because of the restraining displacement and the rotation because of the vertical forces. There can be a framed structure, say you got a, and then you got a beam to join it, so it is a framed structure. It is having its own advantage, disadvantage, but yes, it is another type of bridge. There can be RCC box. This RCC box can be segmental or it can be a monolithic, one unit, and depending upon the length, etc., many times it is possible to do only in segment. Sometimes it is land is available and we can do the work in make the entire monolithic structure. So yes, depends. Then there are RCC slabs. These slabs are generally up to 12 meter. In these slabs there will be two main units which are going to support the track and the ballast mainly, and then this is the third unit which is known as the ballast retainer. So vertical load from the track will come to the middle slabs. However, in order to maintain the bridge, particularly carrying over the LW or over the bridges, larger ballast profile is needed. So adequate ballast profile can be attained by providing the ballast retainer. And of course, it will help in to reduce the width of the bridge. Otherwise, width of the bridge has to increase substantially to accommodate the sloped edge of the ballast. Then PSC girder bridges. This is again like a girder. It can be box girder or it can be twin eye girder. Entirely PSC. Then there can be a PSC composite bridge. Like that, you got a PSC 2 unit like that. And then on top of that, you can have the slab. So it can be a PSC composite. It is a typical example you can see here. There can be a segmental PSC bridges. One after the segments will be joined from the central bulkhead and then the bridge can be completed. It is like this. Of course, we need to take care of a lot of precaution at the time of erection because during erection it is a cantilever structure, and once the erection is over it will be simply supported structure. This is a typical eye girder bridge. Then there is another type of bridge that is called steel composite. In that, the bottom portion of the bridge and it is connected with the shear connector, and the top it will be concrete slab. So it is a steel composite bridge. Sometimes we classify a bridge according to the level of the floor system. It can be a deck type where the track structure is on the top flange. It can be through type when the track structure is connected to the floor system to the bottom of the bottom chord panel, and there are certain members which are vertical and on the top of it also, so that when the train is passing, it is passing through the bridge like a tunnel thing. So all the direction, top, bottom, left, right, everywhere some dimensional clearance is important to check and clear it. Semi-through bridge, when substantial of the girder is uh, above the rail level, it is having some linear means schedule of dimension issue or the clearance issue on the side. Typically, you see that the plate girders here on top of the girder track is there, so it can be shown as a deck type of bridge. This is a through bridge. You can see there. This is the track at near the bottom floor connected to the bottom floor. This is the bottom cord. Then this is the end raker. This is the diagonal member. This is the vertical member. This is the top cord. This is the this raker frame. So in that, it is train is going through the bridge, so it is called the through bridge. Another sketch here is that you see that the track is laid over the stringer, and stringer are connected with the cross girder. Cross girder is every panel point.
स्क्रीन पे डिस्प्ले नहीं है
हटा नहीं, क्या स्क्रीन दिखाई दे रही है अभी?
Yes sir. Yes sir.
Yes sir. Yes sir.
Okay, so it is the semi-through bridge where you can see the height of the here you can see this is the thing. It is substantially when the train will be passing. So substantial portion of the bridge girder is having the side clearance issue. So this type of semi-through bridge is there. So I was telling about the isometric view of the open web girder. Here you see that this is the stringer. Are you able to see me?
Yes sir, yes.
Yes sir. Yes sir.
Okay, so this is the stringer. No, there is some issue. This is the stringer. This is the cross girder. This is the basically end cross girder. This is the intermediate cross girders. This is the bottom cord. This is the top cord. End raker, diagonal member, vertical member. Then this is the sway bracing, or this is called the sway portal. This is called the end raker portal, and this is the top cord. Again, in this you have to understand that the top cord will be under compression. And bottom cord will be under tension. This member is also typically under compression. So in a truss you can say this will be total under tension, whereas this everything is under compression. Now this is another picture of open web girder which is about to be replace underslung girder. This is underslung girder. Track is on top of the top cord. Now, according to opening, we can define the bridge as a minor bridge, major bridge, and important bridge. Basically, this classification is to distribute the responsibility, who is going to check what, who is going to clear, who is going to super check, or who is going to clear the GAD, etc. Basically, bridge is bridge, and as far as the inspection is concerned, it has to be done with the full fettle, whatever type of the bridge is there. But yes, depending upon the human resources distribution, we have classified the bridges major, minor, important. Of course, it will be having the design and the construction and fabrication erection issues also, depending upon the larger the brick, larger the problems. So minor bridge is classified when the individual span is less than 12 meter and the total linear waterway is less than 18 meter. Means 2 9-meter bridges, if the sum is less than 18, it will be, and if there is a 1 15-meter bridge, it will become major. So 15 meter can be major, okay, and 18 meter can be minor. Major bridge is when the individual span is greater than 12 meter or total linear waterway is greater than 18 meter. So 12 meter or equal, 18 meter or equal, then it becomes the major bridge. Important bridge when the total linear waterway is 300 meter or the total waterway is 1000 meter square. So there is third category of important bridges are those which are classified as an important by C or CB due to their depth, waterway, extent of river training wire, past history of maintenance. Means those which bridges are having the problematic past, we try to classify them in the important bridges because their failure may cause the large traffic disruption. Now maintenance of bridge. In maintenance of this, we are adopting a numerical rating system. This is a very interesting thing. We try to identify each and every component of the bridge and try to categorize the bridge based on the severe most numerical rating for any of the bridge component. This is a method of recording of physical condition of a bridge during inspection. Then there is something known as condition rating number. There are from 0 to 6, that is 7 bridge components, and condition of each bridge component will be defined. Then overall rating number of bridge, it is the lowest CRN condition rating number except 0. Then URN is unique rating number, that is a 8-digit unique rating number of the bridge. It has been arranged in following sequence. First will be the ORN, overall rating number, then all these are the 7 CRNs. In that, first item is foundation and flooring, then substructure, then river training work, then bed block, then expansion arrangement, then substructure, superstructure and track. So all these are there, and these component will be inspected individually at the same, during the same inspection, and accordingly this URN or ORN, the CRN will be defined. Then the condition rating, you can see that the condition rating number can be from 0 to 6. 0 means not inspected, 6 means that particular component, whatever is written here, is not applicable. In between 1 to 5 condition rating number is 1 being the condition warrant immediate rebuilding, 2 is typical condition which requires rebuilding rehabilitation on program basis. We have time. There are conditions which require major and special repair. So when we are thinking of major and special repair, still we have enough time. Then condition which require to routine maintenance, it is 4. That means nothing much is to be done. Something can be taken care by the staff employed for this purpose. Then of course we have the sound condition. Having the 5 rating means there is absolutely no problem. Now let us understand all these, what is the implication of these ratings. See, in this case, the first digit we have defined as a value given as 2. 2 means whole bridge or one or more component of its component require rebuilding rehabilitation on program basis. So out of that, anywhere is there? Yes. Number 2 is the bed block or cracked and shaking. So because of the bed block and is the having the severe most condition 2. So because of that, the severe most condition means from the weakest link of the chain or weakest component of the bridge, we define the this overall condition rating. Then 0, foundation and flooring have not been inspected. So foundation was not visible, it has not been inspected, not seen, but this type of situation cannot remain from one inspection to next inspection. So if it has not been seen today's inspection, then in next inspection it must be seen. Then digit number 3 will tell you about substructure, and condition rating 3 will tell that substructure require major and special repair. Digit number 4 is identifying the river training or the protective works. In this case, nothing, no river training or no protective work has been provided, so it is not applicable. Then digit number 5 defines the bed block, and here it is written bed blocks are cracked and shaking, so it has become a poor condition. It has to be given a program basis renewal, so it has been given condition rating 2. Then digit number 6, it is 5, that means bearing and expansion arrangement are good and sound. Then digit number 7 will say superstructure required routine maintenance, so condition rating number 4. And serially item number 8, digit number 8 tells about the track structure require routine maintenance. So like that, right from the foundation arrangement, we have come up to the track. All the 7 components will be assessed, condition rating number is given, then finally overall rating number is to be decided. So numerical rating system is used to create database for management, used to prioritize maintenance activity. Lower numerical rating is a serious condition of the bridge, except 0 means 0 has not seen. So minor bridge URN is only of 1 digit. So out of all these 7, we are taking one and keeping as URN. Instead of that, it can be kept as overall rating number. Right? So last item is, in case of minor bridges, only 1 digit ORN will be given as a URN. And important bridges, for that we are giving a span wise URN. So in case of major bridge, it is like that. For minor bridge, only 1 digit overall rating number is enough. For major bridge, it is 8 digit this URN, right? And 8 digit URN is for the whole bridge. But when it become important bridge, then it will be span wise URN is to be given. So first span is having separate URN, second is separate, like that. I'll just stop here. So I want to know any question or query. Anyone? Okay, let's proceed. Bridge inspection. Bridge inspection is systematic observation of condition and behavior of various components, parts of a bridge. So it is systematic observation of condition and behavior. Now here we have to understand 2 things we are joining together. What are those 2 things? One is that material and its behavior. Second is the structure type and its behavior. And when we combine both the things together, then we will have the behavior of the bridge, overall behavior of the bridge. So if I say a material is concrete or material is steel, and then what type of structure I am having. So if I say material is RCC, and for that I can have the slab, I can have the box, I can have the arch. So all the components, all the type of the bridge will be having a different behavior. Like slab, like a pipe, there are two entirely different structure. Then you can say the arch, again a different structure. So accordingly its behavior will be different. Now if the same structure is being made with the steel, so you can say steel arch bridge, a steel pipe, or a steel orthotropic deck type of structure. So all things will be having a very different behavior. Okay, so that time we need to understand from the material behavior steel point of view. Slab will be having like a slab. So concrete behavior of slab, behavior of concrete slab, and similarly behavior of steel slab that need to be seen. Because the failure mode of the concrete and steel is very different. Concrete generally fail under the tensile forces. Moment compressive forces
Hello.
buckle or yield. Yes. Who is speaking? Any question or query here?
No, sir.
Okay. Now there are certain other bridge mishaps. Kadulandi River, that cast iron screw pile bridge failed because of the failure of the foundation. This is failure of an brick masonry arch bridge because of the scouring below the foundation and the intermediate pier got damaged along with its intermediate support is gone. So eventually this will collapse. Scouring effect below the foundation. This is an interesting case of collapse of Chauras Bridge. Of course, it is a road bridge and it is a 3-span arrangement, middle span being 110 meter, both side span is 40 meter. So same configuration, same design, everything is same. This bridge is being constructed at Chauras field, but another location, that is Gadchiroli, it has been erected. After the failure of this bridge, they analyze it and try to pinpoint the cause, and accordingly try to strengthen the existing bridge which is already put into the service. This is the case of collapse of the footbridge of the Andheri ROB. You can see this region. The main reason for this collapse is the huge corrosion of the at this location you got a cantilever projection. So for this cantilever, if I don't have sufficient strength because of the corrosion, then it will eventually fail. So but what, to prevent the corrosion we need to inspect, we need to maintain it by painting, etc. So if approach is not there, we cannot inspect, then we cannot maintain. This is collapse of FOB near CSTM. In this case, it is being maintained by examined by third party before few days back, and all of a sudden the cross girder connecting both the leaf of truss has collapsed along with the slabs has fallen. So you understand this is also a typical problem or failure related to bridge.
Yes.
Okay, so let's have a quick recap, and we are starting from the bridge inspection. See, bridge inspection is systematic observation of condition and behavior of various component and part of the bridge, right? Here the stress is to be laid on two things. One is the material, another is the structure. So material is, say you are using the steel or you are using concrete, and structure, say you are using plate girder or you are using a truss. So accordingly your material behavior If it is strong in material behavior, means material is strong like steel, it is strong in the tension, and the concrete which is weak in tension. And what are the structure? It is a plate girder, or it is a girder, or it is a truss. So accordingly you have to find out whether it is which type of force is interacting with which type of structural behavior, and accordingly you have to say whether your structure is safe or not safe. Then another point is of major importance is, we are not only inspecting our bridges from the passenger safety, etc. We have to see from the security point of view also. See, bridge is a very important vital link to continue the communication or the transportation system. If the bridge is not functioning properly, or it misbehave, or you have to put the caution, or you have to put it is for unwanted repair, etc., then your entire traffic operation will be suspended, or it will be delayed. You have to put the caution. All those things is not a very good sign, and particularly in the given time, we have to be more careful and vigilant to ensure about the safety and our structures, to ensure the overall security of the system. See, in case of the natural calamities like flood, etc., and if we take care in advance, then it is possible for us to mitigate or let our structure to go through those natural calamities, and it will have a longer life. But for that we need to inspect in time, and we need to take the precautionary measure or repair in time. So that is why we need to understand what are the structural component is getting affected. Because of this covering, open foundation is often susceptible for the cavity formation below the founding level. This is another case of failure during the fabrication and erection of a bridge. It is mainly happened because of not understanding the behavior of the bridge, and the entire erection scheme was faulty. You can see from here at the support, the girder has been simply lifted like this. Here you see the girder has been simply lifted at this. This is the support. So what does it simply say? That it sag in the middle because of the load, and at the end it has been lifted. So it is a 3-span, and this span has been lifted. So at this end, if there had been a proper anchoring arrangement, it would not have the problem. This type of disaster, see, whenever we are having such security deployment is further needed. Basically, lack of the inspection and maintenance of the bridge, it got corroded to a very high level corrosion. It has become very bad structure. It got all its strength lost, and then one fine morning it has collapsed. Only thing you can say that at that time there was no train movement, so it has just saved the life. Otherwise it would have been a bigger disaster. Here again you can see there is a lot of cross girder has been fallen along with the slab connected to it, and it has become a major disaster. It is not a railway bridge, yet it is connecting the railway station to the next footpath. It is a municipality bridge, but yet it has been inspected by third party some time back, and that fellow was put under the arrested and put under the custody. Anyway, this all required inspection input to prevent such type of disastrous performance. It is important to make the structure, it is important to maintain the structure, but maintenance is only possible when it is accessible. Various component of the bridge has to be accessible. So whenever we are constructing, we are designing or conceiving a bridge, at that time we must think about how we are going to maintain it. Unless there is a proper maintenance accessibility to the bridge, it is not of a long-lasting good bridge, because of the natural elements, there will be wear and tear and the damage, and finally it will fail prematurely. So that thing is an important item to be taken care of. What is the objective of the bridge? To assess the structural soundness and fitness, right? To identify trouble at the earliest stage so that mitigating measure can be taken. To keep a systematic record of condition, right? So record of condition and behavior so that in future, next generation, our incumbent may able to understand how it was behaving and it is okay or it is normal or abnormal. Then we need to plan and repair and rehabilitation strategy and program for the bridge. So all these things will come from the inspection. It is a very vital part of maintenance of an asset. What are the action to be taken after bridge inspection is complete? All repair as and when required should be executed expeditiously. जल्दी से जल्दी हमें काम पूरा कर लेना है ताकि ब्रिज को सेफ एंड साउंड कंडीशन में जल्दी से जल्दी लाया जा सके. इसलिए हमें मेंटेन पड़ेगा. फाउंडेशन, फ्लोरिंग, सबस्ट्रक्चर, प्रोटेक्शन वर्क, बेड ब्लॉक, track over bridge and the approaches, superstructure, arches, pipe, RCC box, RCC slab, PSC slab, composite, all bridges, all the location we need to see, and then we need to observe what are the repair maintenance activity needed. In the bridge, we have to mark the HFL level, danger level, so as to ensure that never the natural calamity due to flood, etc., overwhelm our situation and make the structure to fail. Foundation detail and other particulars that should be marked so that we know what is the foundation, at what depth it has been founding, and what is the type of the soil, etc., etc. Clearing the waterway and the encroachments. Many times, if there had not been rain or the flood for the long time, many of those areas which are prone to flood will be encroached. Initially start with the farming, slowly there will be hutments and lot many things has happened, but when the flood comes there will be lot of loss of life and etc., and huge and cry and blame game and all those things starts. Similarly, if because of the other activity waterway has been clogged, then water will not able to flow, it will rise up and it will make the bridge to wash away. So that thing we need to take care. Encroachment is the biggest hurdle, similarly the waterway. So cleanliness is very important in that way. Now, some other marking is painted last. Typically the steel work, because steel painting of steel is the biggest prevention of the or maintaining the steel work. The biggest enemy of the steel is corrosion, and corrosion can be prevented by a layer of protective coating of painting. So that is very important. So you know deplete and it will allow corrosion to set in. So you know what is the age of the painting, accordingly you can take the decision. Then date of painting should be painted in white on the outside of the left girder of the first span. Why it is to be specified typically here, so that you know where to look into that. You need not to waste your time to search the entire structure where it has been painted. You just see and go away. In case of important bridges, the left girder at each end should bear the date of painting. Both side के left girder पे date of painting डाल देना है. Similarly, the highest flood level should be painted distinctly along the year of its occurrence. कब आया? What is the maximum flood level? कब आया? So that you know what is the recurrence time, what is the level of the flood. At important bridges, flood level gauge should be provided to abutment on the pier and end span so that you know what is the water level, how it is being rising, and accordingly you will get the alert and take a precaution in advance. The marking should be made in meter divided into 10 parts commencing from the underside of the girder towards the bed so that you know that what is the height. You need not to measure it. Okay. Flow direction should be distinctly marked in white on the abutment or the pier so that know from which direction to which direction water is flowing. Accordingly, what is your upstream side, and in the upstream side, whether you have got railway affecting work or railway affecting tank, which may release the water or which may cause some trouble to your structure, and if those things are there, you may go and inspect it. Similarly, on the downstream side, if there is anything which is obstructing the flow of the water, thus making the water head to increase and again causing the chances of the washout of the bridge, that you go and inspect. So that is how all these things are important. It need to be marked and then taken care of. Foundation plaques. It shows the particular of the foundation to be fixed over every abutment and the pier, so that you know what is the depth of the foundation, what is the founding level, what is the soil strata. So many things will be given here. It has to be made religiously. This will also give you a clue whether it can be covered during the high flood, or it can be having a tilting problem, or anything you can estimate in the beginning, and then you will get alerted. Name board at the important bridges should be fixed at the either approach at a distance about 15 meters from the abutment, indicating the name of the river and the number and the length of the span. Preliminary information. Bridge plaque containing the bridge number and the direction of flow should be provided with the parapet wall. At all canal crossing, the full supply level should be marked distinctly in the same way as the HFL. For the other bridge, danger level should be distinctly marked in the red on the abutment on the first and the last pier of the bridge, so that you know water is causing the danger to the bridge or not, and when to alert and what precaution is to be taken. Flood reaches or exceeds at the danger level, that you need to check it up. The moment flood reaches or exceeds the danger level, alert it and take other precautionary measures. Danger to the bridge, its approaches or the protection work even before the danger level is reached, such as a disturbance in the alignment and or the longitudinal level of the track on the bridge due to shifting settlement of the pier abutment, or because of the uneven settlement, because of this high water level. Even though it has not gone up to the danger level, there are chances. So you need to watch it. Particularly, what I mean to say that during monsoon season, if the water level started rising, then you get alerted and ready for action to be taken when the need arises. Water on one side of the embankment at a much high level than on the other side, it will result heavy seepage gradient and causing the seepage or piping through the embankment, and finally washout of the embankment may take place. Check on the approach showing sign of settlements and the larger scale of obstruction to the waterway of the bridge. So all these things need to be seen. Some repetition is there, but this is important. Now when you go for inspection, first thing is to read the completion plan, so that you know what are the elements are there, where it is. You must go through the foundation detail, whether it is open foundation, pile, well, or whatever, or you can say it is a shallow foundation or deep, whatever is that, shallow or deep. You should know it. The moment you know it, you will know in the drawing also where it is being founded and what is the soil type. So you can always take a decision what could happen in case of the flood, etc. Then go through the earlier inspection reports. Like recording of the defect in the bridge is important. Similar is the recording of the reading of the earlier inspection report is important, because you will understand the behavior of the bridge. Then go through report regarding repair strengthening carried out in the past. You must know what is the past history of the bridge. Any repair is done or not. If it is done, then where and why it has been done. All those things you know. And then you need to inspect those areas where it has already been repaired again very religiously. Then go through a stress sheet of the major girder bridges. The stress sheet is a very important document wherein it has been given what is the stress level in each and every component of the bridge. If you know that, then you will know what is the reserve strength also is there. So based on that, when your structure is started behaving in a wrong way, you can assess it whether the behavior is wrong or whether your stress sheet is wrong, and accordingly what action is to be done. Normally there are no chances of stress sheet being wrong because it has been done meticulously at different level of care. So you can take that thing, and then you see that if the bridge is misbehaving or component is misbehaving, that means something wrong has happened in the last inspection and this inspection, and accordingly you need to probe into that and then find out what are the root cause analysis or root cause for this type of behavior, do the root cause analysis and then take the mitigating action. Plan any special inspection equipment staging required in advance. Many times it is not possible to reach on the top of the open girder bridges because it is 10-meter height or so, and there are not many arrangements to go on top, mainly because of the security reason, or that somebody can go on top and create havoc. So for that, if you require some temporary arrangement, that need to be done in advance, and once your inspection is over, it has to be expeditiously removed from there also, so that nobody can go and create a mischief. Don't rush to the inspection just for the completion sake. Inspection of bridge is a very thorough and important work. It has to be done thorough, religiously. Every aspect need to be seen thoroughly, and then only we have to prepare the report and see what is required action to be taken by whom. Because as an officer, bridge is being inspected once immediately after monsoon. So once in a year exercise. You will come back after a year. Now these are some of the pictures showing the various arrangements. So this is showing the platform arrangement for inspection of pier and abutment of the bearing, etc., bottom soffit, etc., everything which are near to the top of the pier. This arrangement is that you can, how you will go down on the top of the pier. So for that you need some stair arrangement or some ladder arrangement so that you can get down. These are the arrangement like a side walkway to inspect the sides of the priestess concrete bridge. This is again another view of the side walkway. This is a view of going a ladder which will go down below the bridge, and here you have got the cradle hang through the bridge so that it can move in this direction, and then you can have a thorough inspection of the bridge. When you go for inspection, what are the so that when you see that, you immediately analyze and come to the conclusion. But to see and come to the conclusion, you require a lot of other equipments to carry with you. You need to have pocket tape, chipping hammer, plumb bob, straight edge, steel tape, feeler gauge, log line, thermometer, plumb rod, wire brush, mirror, magnifying glass, waterproof pencil, chalk, pen, etc. Now all that thing, chipping hammer, typically it is needed to chip any loose material deposited to see that whether it is intact or it is coming out. Plumb bob to see the verticality, whether the structure sides are in true or to the gravity or not. Straight edge to check whether there is undulation on the surface or undulation is there or not. Steel tape is to measure the distance between the various components accurately. Feeler gauge will tell you when the structural components are supposed to be in close contact. That you need to check it whether it is in close contact or the gap is closing or it is wide open. Log line, this is to check the score. Thermometer, check the temperature. Probing rod again to check the scour. Then wire brush to clean the debris and the dirt to find out whether the crack is setting inside or not. Mirror to see to reach to the surface which you cannot reach, or you can have a mirror hang with the handle so you can inspect below, or you can stand on the top of the girder and see the soffit of the girder. Some waterproof pencil, pen or paint to mark on the bridge. These are the location I have inspected. There is some issue and what further action is to be taken. Then the center punch to mark it, calipers, torchlight, paint and paintbrush for painting wherever you are say inspecting, you are removing the pen, then immediately apply pen so that it doesn't come in contact with the air early. Then gauge come level, piano wire, steel scale, inspecting hammer, microscope, binocular camera, crack meter. This item can remain in the lab, not necessary to bring it here because you will take the component or the material from here and then examine it. Binoculars is required because many times you cannot reach to the correct location. You may be somewhat away from that, and then with the help of binocular, if you cannot reach, you can bring the structure closer to you, at least virtually, and examine it. In case of concrete, etc., the crack meter is very important. It can be used in steel bridges also. And again, the last but not the least is the common sense, so that you know what is to be done. Otherwise, you don't do mechanically without any thoughtful process. These are the typical, say, caliber, scale, thermometer. What you say? This is for cleaning. This is the plumb box, tape. Like that, so many items are there. Chipping hammer, feeler gauge, thermometer, calipers, binocular, vernier caliper, magnifying glass. Like that, so many things are needed. You should have a kit with you ready on that. You should also ensure that your supervisor has the kit, and if components or this checklist, any item is missing or so recoup it. Now what to inspect? The easiest way of planning for any inspection to have checklist. So you need to prepare checklist, and once you prepare a checklist, then it will be easy for you to do inspection. Now when you are preparing a checklist has to prepare for a different type of the superstructure or different type of bridge and different type of the material component. So for substructure you got different material, for superstructure it will be different material, and so on. So like that you must have the checklist. And now when you have the checklist, you also need to have some of the tolerances limits. So what are the limits has been given in your various steel bridge code or welded bridge code or concrete bridge code or like that. So you find out all those uh, tolerances and note down along with their measurements so that you know whether it is within limit or not. You should also be aware of any rectification work done earlier because these locations are vulnerable, poor and already affected ones, so be careful, doubly careful about it. Then what are the things you can inspect? Foundation, training and protection work, masonry and substructure, bearing, masonry and superstructure. What are those things? Ballast wall, spindle wall, arches and pipe and boxes, bed blocks, steel this girder and slab, track, etc. These are the so many items which you need to inspect. In case of foundation and flooring, visual examination is difficult because it might be covered with the muck. Observe exposed elements, take a scour reading, verticality of abutment and pier. Water inspection. For the foundation, underwater inspection is slightly difficult. Then inspect quality of material, dry season and the telltale. Permanent kink in alignment, tilt of the pier, etc. See, these are the things you should know it, and you need to check it out because they are the vital sign of performance of the bridge. Discover over foundation, quantity of filling boulders, filling of the boulders or the earthwork, availability and requirement of the flooring. You need a floor there to channelize the water and to run faster so that deposition does not take place. But if the approach is already silted, then the water will stagnate, it will not function properly. So what you need to do, clean, do it. You need to reset the flooring system, do it. So whatever action is to be taken, that need to be taken. And again, the flooring system, we are putting the stone such a big so that it cannot be easily lifted by the water forces or what you say, the scouring effect and settled and lost somewhere. So you should have these sufficient big and sufficient area to be covered. Then whether you can inspect and repair the curtain wall or the top wall, they are important because they are preventing the sufficient hydraulic gradient and the piping structure if they had been done properly. Then obstruction to the waterway, if anything is there because of the foundation, if it is there, then you have to correct it and set right the flowability of the or the waterway. You need to make it. Now some of the typical past experience example, because of the scour, some portion below foundation will wash away, gap will be created, and if there is a gap, then foundation or the pier etc. is having a tendency to tilt. Now many times that tilt may happen, many times it doesn't happen, many times crack develops, and many times it happens, crack develops and later again it has failed. So this is a typical example where you can see the crack has been generated in this way and it is a huge structure running line, so it is not possible to repair it. So instead of thinking of instead of replacing it, repair has been thought and then it has been carried out. Now what are the other thing also? If there is a scour below and girder is leaning, then there is a possibility of the lateral sway also. So this thing need to be seen, need to be correlated, and then you have to take a call whether it is a problem of the masonry or problem of the foundation or something else. Now this type of misalignment cannot be taken care easily. You need to do a lot of effort on it. You need to settle or correct your pier abutment, then you need to use the mechanical means to restore the alignment. So yes. Now pier and abutment. So in that case, see that there is a crack has be as if it is an expansion joint, but this thing is really worried why it is happening. So inadequate or abnormal clearance between the ballast wall and the end girder. If the distance is very high, then there is a problem of placing the sleeper. If it is very low, then there is a problem of expansion or due to hot weather. So it requires again your attention. So leaning, bulging of abutment, we'll see some other example. Then abnormal level difference, one end is the other end, how it can happen. This all tell whether your substructure is stable or it is having leaning on one side. Then tilting of unequal settlement. Then sinking of foundation, it may be crack pattern. Uneven, whether the sign of uneven settlement is there. Also check the weathering, action of the weathering or the climatic forces or the natural forces on the bridge material. Now undermining of the foundation, it may be because of this cover or it may be undermining because of the you say hydraulic gradient. So anyhow, if it is happening, then this portion of the structure is having tendency to make this as a fulcrum and tend to settlement of the pier and stop the and recording and this tilting of the pier can be prevented. So here you can see that time the tilting happened and the structure is moved along, a lot of gap is being created. Here also you can see that there is a longitudinal shifting in the girder and the pier. Okay. Okay. So what I was telling, the thickness of clay layer here is smaller compared to the clay layer here. So settlement of this layer, say 1, this portion is less compared to this portion. When this thing will happen, then this portion of the girder, this portion of the pier or abutment is having tendency having a less support at its foundation. So it is having a tendency to lean toward this side. And in that way, when the wing wall, in that way the structure is tend to rotate, a crack will develop in like this. So depending upon from where the crack is developing, this crack typically will start developing from the top and keep on propagating to the bottom. It is like a cantilever separation. So that we need to understand. Now when we are going to inspect, we need to inspect the condition of the masonry or the RCC work, right from A1, P1, P2 and A2, like that we keep on moving from one end to other end. We need to check whether there are cracks, hollow masonry requires grouting, how you do that thing. If the crack is visible, you measure it, what is the size of the crack, whether the crack is, you put the telltale sign, write the date, again come back after a few months and check it. You also check what is the crack thickness and then you see whether the crack is expanding or not, and accordingly you have to take some decision whether the grouting is to be done or whatever is to be done. Similarly, if there is a hollowness, you put a rubber pad and hammer it, then you will able to see that what type of sound is coming out. If the sound is coming very dull, that means the structure is hollow behind, and then you need to do again some sort of filling of that hollowness. Then pointing of the masonry joints. When the masonry joint become weak, they need to be pointed. Otherwise, what will happen? That will become the potential source of water increase further. And then next step will happen. The joints will become further loose and deplete, and finally the blocks will come out. So in that way, the damage started increasing. So that need to be pointed and make the joint perfect. Leaning of abutment, pier along the track and the transfers to the track. Like I have shown you previously some example how it can lean because of the scour or the settlement of the foundation. So if the abutment is leaning towards in the longitudinal direction of the bridge, or it is leaning perpendicular direction to the bridge. What does it mean? Perpendicular direction typically will happen because of the scour or the erosion of material below the foundation. Leaning of it towards in the direction of along track center line, any leaning, it is because of the abutment leaning, maybe because of the earthwork, and the pier etc. maybe because of differential settlement or the scouring at one side. Many times it can happen some damage to the foundation also, and that makes the your structure slightly weaker and hinge forming. Condition of wing wall and the return wall. Check it out. Mostly masonry, it can be set right. Provision of cleaning of the weep holes. Masonry below the bed block. Condition of jacket masonry. See, this is the case of when tracked and finally it has fallen like this. See, this is the broken stone. This is the crack development. Some pointing has been done. Like that, all those things you need to observe and see that. See,
This
here you can see
meeting is
that
being recorded and
zigzag
summarized.
pattern. So this clearly indicate that something is moving this end. That means the structure has started cracking. Likewise, in the substructure you have got lot of this crack pattern. That also indicate a poor condition of this structure. It is not going to fail immediately, but it is alerting you. You should see and get alerted. After that, what is needed, you should examine, open it and check it out, whether it is the masonry layer is going or it is something else. Check it out. What are the protection works needed to be inspected? That marking of HFL, danger level, etc., protection of bank up to the HFL, top level of guide bund and their slopes, condition of flood protection work like rat and raw, condition of boulder pitching with the pointing and the stone in case of a buried abutment. So all need to be examined and seen whether it is in the good condition or not. Condition of ballast wall repairs. Look for a proper seating of bearing and crushing of the bedding material may create the loose bed blocks. All those things need to be seen and action need to be taken.